Hello everyone. Today we are going to be going through the Algebra A Unit 2 study guide. The test again is coming up, so we want to make sure that we are well prepared and familiar with all of the order of operation rules. Again, this unit's going to have a lot of PEMDAS in it, so make sure that you review that before the test. Please excuse my dear Aunt Sally. So just make sure you kind of have those rules in the back of your head when you're going through this review packet. A reminder, this review packet will not cover every single problem, but it will hit the majority of big parts that will be on the test. So when you're looking at the first problem, pretty straightforward. The directions say that you are solving each of these equations for the given variable. So in problem number 1, you'd be solving for y. In problem number 3, you're solving for m, and so forth and so on. So just make sure you understand that. One of the big rules that we talked about in this unit when solving for a given variable is making sure that all the variables get to the same side. So when you're looking at problem number 1, you have a y on the left side and you have a y on the right side, and therefore that's going to cause a problem. Now before you're allowed to move anything, you need to A1 distribute, 2 combine if necessary, and then you can start adding and subtracting to move it to the other side. So when you're looking at this first problem, you have this 5 out in front. This rule that I'm about to cover will come up in play in number 7 down here, and you'll see why, but keep this rule in mind when we get to number 7. So when you're looking at this very first one, you have a 5 out in front. That 5 is what needs to be distributed. So remember, the distributive property says that this 5 is going to get multiplied by y, so that becomes 5y. And then this 5 is also going to get multiplied by 5, and 5 times 5 gives you 25. So all we really did was distribute. Now you should notice that there's a y on this side and a y on this side. Some of you guys in class might have called it or learned it before as the pipeline. I personally like to think of it as like a brick wall. You know, if you go through and throw in some equal signs, kind of looks like a brick wall. So what that brick wall says is, if you want to move something across the wall, you're going to need to change it. So if it's a 5y, I can't just go ahead and throw a 5y on the other side. It's not as easy as just taking that 5y and moving it to the other side. You actually need to think of it as, if this is a positive 5y, to get it to the other side, I'm going to have to subtract a 5y. Because if we look at that just in the sense, if I have 5 over here and I subtract 5, what am I left with? 0. So if I have 5y and I subtract 5y, what am I left with? I'm left with 0. But then I still have this 25 over here, so on this side I'm going to be left with just 25. Then whatever I do to one side, I have to do to the other side, so I'm going to go ahead and subtract 5y. Now what's really happening, remember common terms, I'm not going to touch this 1 because the 1 doesn't have a y attached to it. This has a y and the 4 has a y. So what am I going to do? I'm going to have 4y minus 5y. Well, what's 4 minus 5? That's negative 1. So what am I left with? I'm left with a negative 1y. So I have negative 1y. Don't forget about that plus 1. Going to go ahead and tack that on. He didn't change it all because he didn't have a y. Then I'm getting really close to having that y by itself, but right now I have this plus 1 right here. So how do I move it across the brick wall? You do the opposite. So if this is a plus 1, how do I move it over? I subtract 1. And 1 minus 1 gives me 0. Therefore, I'm left with a negative 1y equals, remember to subtract the 1 on the other side, 25 minus 1 gives me 24. Then it's almost done. You're almost done. You have a negative 1y equals 24. This negative 1y is not a subtraction of 1. It is more along the lines of negative 1 times y. There's always technically a multiplication between the number and the variable. So if I have negative 1 times y, what's the opposite of multiplication? Division. So I'm going to go ahead and divide by negative 1. Negative divided by negative just becomes positive, so I'm left with just y. Technically it is a 1y, but you don't really need to write the 1 unless you have a burning desire. And then 24 divided by -1 just becomes -24. That's going to be your final answer. So that's a very basic problem, but had a lot of different rules in it that you're going to want to keep in mind. Number 2 is going to be a very similar property, except you're going to be distributing on both sides. Careful with those fractions. If you don't know what 1/2 of 8 is, you're going to just want to do 1/2 times 8. You could also type that in your calculator as 0.5 times 8 and 0.5 times 12. Don't lose track of that negative sign right here. And then the 1/3, you're going to want to be careful with that. Again, that doesn't come out to 0.5. That is a 1/3, not a 1/2. Make sure you're keeping those straight, but you're taking 1/3 times -12. So I'm going to let you go ahead and solve that. Number 3 and number 4 have that be careful in there because of the location of those fractions. So you'll notice this one here, the m, or the variable that you're solving for, is in the top portion of the fraction. So it is part of the fraction. So in order to touch it, you need to get rid of the bottom first. Versus number 4, this fraction has nothing to do with this -2. It's its own little, universe. So if you want to touch that x over 3, you need to get rid of the 2 first. So that's where these two kind of vary. Keep in mind that this is a division of 4. So how would you get rid of the division of 4? You're going to go ahead and multiply both sides by 4. So that will leave you with a 6 minus m equals 7 times 4, 28. Now it's pretty straightforward. Bring the 6 over. Keep in mind, a couple people in previous years have a really hard time of trying to figure out how to get rid of the 6. This is technically a positive 6. So in order to bring it across the wall, you're going to need to subtract 6. So just keep that in mind. If there's no symbol out in front, it's assumed to be a positive 6. Versus over here, there's a negative sign out in front of the 2. So how would you get rid of it? By adding 2 to both sides. That will leave you with a negative x over 3 equals 27. That negative sign, it doesn't really matter whether it's on the top or the bottom. I personally, in this case, just to save some steps, you can go ahead and throw it on the bottom. Doesn't really matter. It'll, if you want to put it on the top, that's perfectly fine. It will still give you the same answer. It's just going to be a little quicker if you put it on the bottom, because now you have x all by itself, but it's on the top. So how do you get it completely by itself? Well, currently it's x divided by -3. So what's the opposite of divide, just like we talked about over here? Multiplication. So you're going to multiply this side by a -3, and you're going to multiply this side by a -3. And then that will cancel these out, leaving you with just x equals your answer. Now I said earlier that we were going to talk about number 7, and not to forget the rules that we talked about in number 1. The big thing that we're going to talk about in number 7 is the fact that, and I pointed to this earlier, there's parentheses here, so that means that there's some form of distributing going on. In the left side of it, you can clearly see that the 5 is going to be what gets distributed, but on the right-hand side, you see parentheses, but you don't really see a number out in front, so you're kind of like, well, what am I going to distribute? It's kind of like saying, what if I had a 1 out in front? Kind of a silly question, I understand, because 1 times anything is itself, but you would still technically be distributing that 1. This negative sign, all it's really saying is that you have a -1 out in front. So if I distribute a -1, that's going to become -5r, and then -1 times 3 gives me -3, right? So that's what's happening right here, is it's technically a -1. So, that 6 is hanging out front, but you're going to take -1 and distribute it to each of these pieces. So -1 times 5 gives me -5r. -1 times 3 gives me -3. Okay. And then on the other side, hopefully if you distribute it properly, you got this 10r minus 15 plus 4r. Now before you go any further, make sure that you check both sides for anything that can be combined. It's not going to make a huge difference if you just like, I want to get everything over to one side and then I'll combine. It's not going to make a big difference, but it will draw out your problem a little bit, and you're going to be writing a lot of stuff multiple times. So if I look on just the left side, I see that these two can be combined to become 14r, and then the 15 is all by himself. On the other side, I can see that I have a 6 and a negative 3. If I combine those, that's going to give me 3, and then I'm still going to have that minus 5r. Now at this point, it's just a matter of bringing the r's over to the same side. Doesn't matter left or right. In this case, I'd probably bring the r over to the left-hand side, and then take this 15 and bring it over to the right-hand side. But that's your preference. So that's all the reviewing we're going to do for that one. If we go ahead and flip over to the next page, these are some questions that may appear on the final, and people always tend to forget them because when you first learn them, they're kind of easy, but later in life, they're actually going to become kind of handy, and therefore, you want to hold on to this skill. So when you're talking about consecutive integers, all they're really saying is 3 numbers that come in a row. So if I said, what are 3 consecutive integers? You might say 1, 2, 3, great, you can count, perfect. Maybe you wanted to be different and you said 100, 101, 102, that's fine as well. Those are consecutive numbers. They do give you a little stipulation that it does sum up to 33. So if I looked at these first 3, let's just say I guessed, 1 plus 2 plus 3 gives me 6, not 33. If I add these up, still not going to give me 33. So we need to think of 3 numbers that do in fact give me 33. So let's say that my first number, whatever my first number is, let's just call it n. I don't know what it is, but I'm going to call it n. My second number, whatever it is, let's look back at these examples. There's a difference of 1 here. My first number, I added 1. My first number, I added 1. So here, all I'm going to do, take my first number and add 1. And what about my third number? Well, my third number, I took that first number and I added 2. I took that first number and I added 2. So I'm going to take my first number and I'm going to add 2. Whatever my numbers are in this world, I have n plus 1, n plus 2. Those are my 3 numbers. They told me that the sum of these 3 numbers equals 33. So if I go ahead and add these 3 numbers, should give me 33. Now that you have your problem set up, all you have to do is combine like terms. Here's an n, and n. If I add 1n plus 1n plus 1n, that's going to give me 3n. Then I also have this 1 and this 2. If I go ahead and combine those, that's going to give me 3 equals 33. And then I'm going to go ahead and let you finish that one out. The odd integers people do struggle with. If you look at our examples over here, 1, 2, 3, 2 is not an odd integer. So if I tried this one, 2 is not odd. It would not fit this criteria. But if I chose 1, 3, and 5, those are all odd numbers. And they are consecutive because the numbers in between are evens, so they don't count as consecutive odd integers. However, when I add these up, it does not give me 30. So if I go through the same process like I did in the first one, I want 3 numbers, so number 1, number 2, number 3. I want 3 numbers. My first number is always going to be n because it's the first number in the order that I'm listing. My second number, again looking over here, when I went from 1, my first number, to my second number, this time I added 2. Now it seems a little intuitive and you're like, oh well 2's even, that can't be. The thing is, no matter what, whether I'm looking at odd numbers or maybe I'm looking at even numbers, from my first number to my second, I add 2. From my first number to my second number, I added 2. So it's always going to be adding 2 no matter what, whether it's odd or even. So these directions doesn't matter whether it says odd or even, you're always just going to be adding 2. Now when I'm looking for my third number, I'm going from 1 to 5. That means I must have added 4. Even if this said, maybe this didn't say odd, maybe it said even, when I go from my first number to my third number, I added 4. So I'm always going to be adding 4. And then the process is going to be the same up here. You're adding all these together to give you negative 30. Now in a problem like this, when it says odd or even, you do want to check your final answer. And if it comes out that your problem, let's say, in this case when you solve for n, you're going to get that n equals negative 12. However, when you get this answer, yes, you would go back up here. Don't forget, that's just number 1. I need to figure out what number 2 is. So I would come over here and say, okay, well, what's n plus 2? That's going to give me negative 10. Okay, well, what about my third number? That's going to be n plus 4. So if I add 4, that's going to give me n3 equals negative 8. You're like, great, I found my answers, I'm all done. It's negative 12, negative 10, negative 8. However, they want odd integers. Are these 3 numbers odd? No. So the answer to this, no solution. So just kind of keep that in mind when you're looking at these problems. Yes, you found an answer that works, but it doesn't meet the criteria, and you might not have done anything wrong. You did everything right here, but just keep in mind that sometimes that's possibly going to happen. Next up, you have some of the most favorite test problems that we love giving, because they're not actually asking you to do any work whatsoever. The whole problem is solved for you, and you're like, yay. However, they come right out and say that Roger made a mistake, and you have to figure out where that mistake is. There's 2 different ways that you can approach a problem like this. One of the most common ways to approach it is to, unfortunately, solve it yourself. So if I look at this problem, don't even look at his work. Again, this is just one method. Don't look at his work. Just say, how would I, as a student, solve this? So I go ahead and I take my problem, and I say, okay, I need to get n by itself. So let's get rid of the 9. This is a positive 9, so I'm going to go ahead and subtract 9 on both sides. Okay, perfect. So I have negative 19. Now I have m divided by 4. How would I get rid of a divided by 4? Well, I would go ahead and multiply it by 4. That gives me m equals negative 76. Okay, so I solved my problem. And I did, in fact, get a different answer than him, so odds are he made a mistake. So let's go ahead and say, what did he do differently? Okay, well, right off the bat, he did multiplication by 4. Well, so did I, but I did it later, because I know that I cannot touch this fraction until I get that fraction by itself. So that would be his big mistake, and you can describe it in any way you want. Maybe you said, oh, he multiplied too early. I'd accept that. Maybe you would say, oh, well, he can't multiply until he gets rid of the 9. I would accept that as well. So there's a lot of varying answers, but that's kind of your train of thought that you want to do. Is solve it yourself, and then go back and say, where did our answer differ? So if you look at number 2 over here, you'd go through and say, okay, well, I need to distribute this 2. That's going to give me, what's negative 2 times 1? That's negative 2. What's a negative times negative? Positive 2h. And then on the other side, I don't have to distribute anything. So right off the bat, I barely had to do any work. You could continue solving this, that's fine. But I see right here, I have a negative 2. They have a positive 2. That's a problem. Right there, that's your answer. You'd say, oh, they lost a negative sign. Boom, done. You don't always have to solve the whole problem. Sometimes it'll happen early on, sometimes it'll happen later on. But you are going to want to kind of solve it yourself. Now maybe you can just look at his work. This is another option. If you don't like trying to solve it yourself, look at his work and say, okay, so first he distributed. Negative 2 times 1. Oh, wait a second. If I were to distribute this, I would get negative 2. That's a problem. So you can work through their work and figure out where their mistake is, or you can solve it yourself and compare. Those are your 2 options there, how to approach this. Down below, I won't review this too much because it was in our last chapter. These are the ones where you're going to want to read them, write them as an equation. The only difference between this chapter and last chapter is this time they're actually asking you to solve. So last chapter, we would look at this and say 6, okay, that's a number, multiplied by the sum of, so sum of meaning parentheses, 2 and some number. So let's just call it n. Is one of those magical equal words, is 48. If this multiplication symbol confuses you, you don't technically have to have the multiplication, you can just have the 6 out in front. And then last chapter, we would have just stopped there. However, in this chapter, we want to solve for n, so you would want to go ahead and say, let's distribute. That's going to give me 12 plus 6n equals 48, and then you need to get the n by itself and continue solving that. So that problem is not done, but you are going to finish it, and have fun with finishing it. Moving on to the last page then, as far as the review goes. Most of these are just kind of word problems you want to work yourself through. The first one, just be extra careful with where the magical words like plus or times are. So this one says he pays $30 plus 15 per gigabyte. So the 15 and the gigabyte are kind of paired up together. Therefore, you're looking for the 15 and the G to be paired up. So right off the bat, you can kind of go ahead and rule these out. And then it says that I want 30 plus 15G. So where do I see 30 plus 15G? You might not see it right away, but technically it would be right here. You have a 30 plus 15G. It doesn't really matter whether you write it as 30 plus 15G. It's like saying, hey, what's 4 plus 2? 6. Well, then what's 2 plus 4? Still 6. So order doesn't really matter. Over here, this one doesn't make a difference because the equal sign is over here. So if I went ahead and said, oh, let's solve for C, I'd go ahead and subtract 30. That's going to give me 15G minus 30, not plus 30. So in that case, if you weren't sure which one it was, you can go ahead and solve for C, and then that's going to tell you which one you want to be looking at there. 14 is similar to the previous page. It's just a little more wordy, so you need to pick out those key words and then work from there to set up your equation. Careful with the part that it says he gave half of his cherries to his friends. So if this is the number of cherries he has, he's going to take half of that amount. Then it says he went ahead and gave another 4. So it doesn't really matter however many he had. Maybe he had 6. He gave away half. So now he's at 3. Then he's going to automatically give away another 4. So this has nothing to do with a fraction. It's just automatically taking away 4. So whatever he started out with, he took half. And then from that half, he took away 4. So just keep that in mind. And then it says his total amount that he has at this point is 25 cherries. And then solve. Down below, 16 is just one that you should think about if you want to write it down, if you want to verbalize it, however you want to answer 16. Yes, I skipped 15, but I think you can figure that one out. But 16 is just saying, what does it mean if I said, hey, I just solved this problem and I got all real numbers, or maybe I got infinite solutions. These two things mean the exact same thing. Infinite solutions just go on and on and on, just like all real numbers, consider all real numbers. So what that's really saying is, if I solve a problem, if I have 5n plus 1 equals, this seems like a blunt example, but 1 plus 5n. If I gave you that problem and you went ahead and solved that, you'd say, okay, well, let's get the ends on the same side. Well, when I solve this, what's 5 minus 5? 0. So all of a sudden, I'm left with 1 and 1. What does n equal? This equation doesn't actually come out and say n equals this. Because when you get to your final answer, you got a true statement. 1 does, in fact, equal 1. So what this is saying is that no matter what number you plug in for n, it will always work. However, if I got a problem like this, let's say I alter this just a little bit. Let's say I made this 2. I would still subtract 5n, but what would my final answer be? 1 equals 2. Does 1 equal 2? No. Therefore, this particular example would be no solution. So just keep that in mind. If they're looking for all real numbers, by definition, the equation will come out true every single time. No matter how you solve 5n plus 1 equals 5n plus 1, no matter how you solve that, it will always come out to a true statement. Okay? But if it comes out as false, keep in mind that will be no solution. 17, I'm going to let you solve that one as well. It's very similar to the previous page down here, the ones where it said write the equation and solve it. The only difference is here, saving you some time, you don't have to solve it. So you're going to go ahead and write this equation and just be done with it then. That is the review for Unit 2. Please feel free to go back and watch any of the material that you missed. But otherwise, if you're solving these problems, please make sure that you log on to Canvas. You should already be on Canvas, but make sure you're going back and checking it with the key, because there's some problems that I did not go over. I did not finish going over number 2. So when you finish going over number 2, you need to check your answer. Don't just solve it and assume that you're the world's smartest mathematician and that you got the answer right. Please, please, please go back to Canvas and check your answers.